We're now going to fill in a unit circle chart that's posted as a PDF on Canvas. What we're going to work with is the unit circle and the special angles. In my regular in-person class, students have to learn to memorize this chart. They have to actually fill in all the spaces as a closed book quiz, so they have to have it all memorized and be able to fill it in. Now remember, the unit circle has equation x squared plus y squared equals 1. And what we care about in trigonometry about the unit circle is that the points on the unit circle have coordinates that correspond to angles in standard position. The x coordinate is always the cosine of an angle. The y-coordinate is always the sine of an angle. So the coordinates are always of the form cosine sine. Now what we're going to do is first we're going to fill in the angle measures. We're going to use both degree measure and radian measure. And then we're going to go around and fill in the values of all the trig functions. And really, if you just know a few basics, you can fill this whole chart. I don't even always have it memorized. I just know how to fill out the chart using symmetry, and then I get the correct values in the right place. Okay, so there's just so you understand what we're filling in here, there are degree measure markings. This is 0 degrees. Right next to it is radian measure. Of course, 0 degrees and 0 radians is the same. And we're only talking about the special angles. So we have a 30 degree terminal side, 45, 60 degrees are marked. So this is 30 degrees here, 45 degrees, 60 degrees, and then we jump to 90 degrees. So notice that they're not all equally spaced, because we haven't actually indicated 15 degrees, right, would be right here. And if you want, some people like to think in terms of 15-degree increments. That helps them remember. So you would have to, imagine filling in. Don't actually write it in. Just imagine a 15-degree angle, 30, 45, 60, 75 degrees is not marked, and then 90. And you can actually go all the way around the unit circle by adding 15 degrees each time. Now, actually, let's fill in some more of these values. I want to jump all the way to 180 degrees. We know straight angle. We know 3/4 of the way around is 270 degrees. And then there's a second marking that we can fill in at 0, because that's like 360 degrees, full circle. And let's get the degree measures filled in all the way around now. So I could either count by 15, or you can also just count by increments separately. For instance, I could use 45 degrees. Watch this. Like 45 degrees, 2 times 45 is 90. 3 times 45 is 135 degrees is going to go here. 4 times 45 is 180. 5 times 45, 180 plus 45 is 225 degrees, plus another 45 is 270, plus another 45 is 315 degrees, plus another 45 is going to take me back to positive x-axis and 360. So you could count by increments separately. Then you could do 30-degree counts separately. 30, 60, 90. 90 plus 30 degrees is going to be 120 plus 30 degrees. Now I skipped the 135. 120 plus 30 degrees is 150. 150 plus 30 degrees is 180. 180 plus 30 degrees is 210. Skip the 225. 210 plus 30 degrees is 240. 240 plus 30 degrees is 270. 270 plus 30 is 300. Hop over the 315. 30 plus 30 degrees is 330. And then 360. So Again, an alternate way would be to just count 15, 30, 45, 60, 75, 90, 15 each time, understanding that we're leaving some of those 15-degree multiples out. Now we also got to know the radian measures of these angles. Let's fill in some of the easy ones. We know 180 degrees is pi radians. 360 is 2 pi. 90 degrees is pi over 2. And it helps me to think of my multiples of pi over 2 as quarters of the circle, right? So 90 is pi over 2. I can count by pi over 2. 2 pi over 2 is 180. 3 pi over 2 is 270. 4 pi over 2 is the same as 2 pi 360. 30 degrees, we've already memorized that that's actually pi over 6 radians. 45 degrees is pi over 4 radians. 60 degrees is pi over 3 radians. And now we would have to continue around the circle with those. Again, you got a choice. Again, you could use multiples of 15 degrees in radians. 15 degrees is pi over 12 radians. So some people like to think pi over 12 is 15 degrees. 2 pi over 12 is 30 degrees. That will reduce to pi over 6. 3 pi over 12 is reduces to pi over 4. 4 pi over 12 reduces to pi over 3. 5 pi over 12 we don't mark. 6 pi over 12 reduces to 90. So that's one approach you can take to fill this in. You can go all the way around the circle in that way. Or what I'm going to do is I'm going to kind of do what I did before. I'm going to rely first on multiples of 45 degrees. So I'm going to go 0. Pi over 4 is 45. 2 pi over 4 is here. 3 pi over 4 is 135 degrees. 4 pi over 4 is 180, same as pi. 5 pi over 4 is 225. 6 pi over 4 is 3 pi over 2, same as that. 7 pi over 4 is 315. And then 8 pi over 4 would be 2 pi. So if you can count those multiples of pi over 4, you can hit the angles we just marked. Now I'm going to count by pi over 6, all right, 30-degree increments, which if we think of the unit circle cut into 30-degree pieces, I'm going to miss those pi over 4s, right? Those diagonals for pi over 4. And see, I can count by multiples of pi over 6. 1 pi over 6, 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6, 4 pi over 6 reduces to 2 pi over 3. Then I get 5 pi over 6 at 150. 6 pi over 6 is 180. 7 pi over 6. 8 pi over 6 is 240, but 8 pi over 6 reduces to 4 pi over 3. 9 pi over 6 is just 3 pi over 2. 10 pi over 6 reduces to 5 pi over 3. 11 pi over 6 I write down. And 12 pi over 6 is full circle. So there we got our radian measure filled in. And so a couple yellow cards, you know, I've been referring to, this is really what we're working from, the basic idea of the unit circle. X coordinates are cosine, y coordinates are sine. And then we got to use our memorized information about the sine and cosine values of 30, 45, and 60 degrees. So that's going to get us started on this chart. And so here I'm going to put, let's see, the cosine of 30 degrees is square root of 3 over 2. Cosine goes in the x-coordinate. Cosine of pi over 4 square root of 2 over 2. Cosine of pi over 3, cosine of pi over 3 is a half. And then I actually do the reverse now for the sines. 1/2 for 30 degrees, square root of 2 over 2, square root of 3 over 2. So we do just have to know those sines and cosines and where to write them for the special angles 30, 45, 60 degrees. Now, another thing I meant to do, and I maybe should have even done this just before, the quadrantal angles are easy for us to fill in the sine and cosine because we know those coordinates on the unit circle. At 90 degrees, this is the point 0, 1. X is 0, y is 1. Rely what you know about intercepts. Now that means the cosine of pi over 2 is 0, the sine of pi over 2 is 1, quadrantal angle. At 180 degrees, we have negative 1, 0, x is negative 1, y is 0. At 3 pi over 2, or 270 degrees, we have 0, negative 1. And back at full circle, 360, or just 0 degrees, we have x is 1, y is 0. Cosine of 0 is 1, sine of 0 is 0. Okay. Now, to get the remaining values as I go around, I just like to use symmetry of the circle. And let me show you what I mean by that. So I'm just going to focus on the 45 degree multiples here. And I'm going to draw that rectangle from, remember our reference angle discussion, because these are actually, I'm marking the angles that have 45 degrees as their reference angle. So these will all have almost the same sine and cosine. It's just that some are negative, right? And if you can just sort of imagine that going straight across, straight down, straight across, back, straight up, we hit the angles that will all use square root of 2 over 2 for their sine and cosine. But some of the time, they have to be negative. If I go straight across now, because I'm in the second quadrant, the x-coordinate is negative. I get negative square root of 2 over 2. Y-coordinate is positive. If I come down, both coordinates are negative. Both are negative. And if I go over to the fourth quadrant now, x is positive and y is negative. And I can do the same type of thing with 30 degrees and 60 degrees. Now you shouldn't have to draw this each time, but I want you to be able to visualize the red rectangle, the blue rectangle now. In the blue rectangle, I'm marking the angles that have pi over 6 as their reference angle. Sorry, I'm smudging a little bit here. And so the thing about going straight across, straight down, straight across and back, these sines and cosines will all match up with pi over 6, except maybe we just have to know when to put in the minus sign. So when I go straight across, I can write square root of 3 over 2 1/2 in the same order, but now I know in the second quadrant, x must be negative, y is positive. When I come down to 7 pi over 6, x is negative and y is negative. And when I go across to 11 pi over 6, x is now positive, still square root of 3 over 2 in the first position, but y is negative, so I got to write negative 1/2 in the second position. And now you can do the same thing with the four angles that have pi over 6 as their reference angle. I won't draw a rectangle here, we'll just kind of visualize this in our minds. So I'll take 1/2 square root of 3 over 2, go straight across. X becomes negative, so I have negative 1/2. Y stays positive, square root of 3 over 2. I come straight down, same, both x and y are negative. Negative 1/2, negative square root of 3 over 2. Go straight across. Let's see, x is now positive 1/2. Y is negative square root of 3 over 2. And I think we got everything filled in. So notice, first quadrant, x and y are both positive. Second quadrant, x's are negative, y's are positive. X and y are negative in the third. In the fourth quadrant, x's are positive, y's are negative. So you should be able to fill in that entire chart by hand. You should really have it memorized. But again, see how I used what I knew about symmetry and the relation of reference angles here to help me fill things in. So here's a version with all the values maybe a little bit easier to see. And there it is, the unit circle. Now this is just the special angles. There are lots of other angles on the unit circle. We just don't have their sines and cosines memorized. They're still there. This is just the special angle diagram.